Hello, hi, I'm Nick Burgess. I'm a quant analyst, and today I'm going to talk to you about C++ environments, how to create professional environments that you can use for algo quant trading. Now, in part one, in our previous video, we talked about Visual Studio and the Windows environment. We talked about how to sort of set up C++ coding environments in Visual Studio, and we went through the C++ build process. We talked about the compilation process and the linking process, which is the two parts of building a C++ project. We went through all the property pages for the compiler settings, and we also went through all the property and configuration settings for the linking process in Visual Studio. And that's quite a manual process. You do get used to it pretty quickly, which is great, but it is fairly manual. And today in part two, we're going to talk about how do we automate this. And we're going to be looking at the CMake build framework. And the CMake build framework is a cross-platform framework that automates the generation of build files on the platform of your choice, including Windows, Linux, and macOS. So the format and the way we're going to proceed is as follows. I'm going to present to you some PowerPoint slides, and I'm going to break that down into chapters. So if you go at the bottom of the YouTube video, you'll be able to jump to the sections that are most of interest to you. And then after I go through the PowerPoint slides, which we'll use as a reference material, we will then proceed to a live example of how to use CMake. And we'll generate the project files, we'll run our code, and we'll find it's much simpler, it's very automated, and we don't have to worry about that manual configuration of compiler and linker settings. And this will allow your projects to be very consistent between users and between platforms, so you can go ahead and then build. You can have your local environment, perhaps in Windows, for your developers. And when you're ready to ship your code into production, maybe you want that on a server that runs on Linux for speed, performance, and for other purposes. And that server may be a super fast server as well. So the CMake platform allows you to transport your code and generate the build files that you need to run your code on the platform of your choice. We're going to be looking at the Windows platform, but I'll also be showing you how to run the code on Linux and macOS. So without further ado, I'm going to present you the slides, and then I'm going to show you the live example and all the reference material and the sections. If you want to jump ahead to sections of this video, they're all in the bottom of this YouTube video. Okay, so I'm going to share the screen. Here we go. Okay, now let's run the slides. So here we are, the CMake build framework. This is part two of how to set up C++ for algo quant trading and other professional environments. So we looked at in part one, we looked at Visual Studio for Windows. I presented an online emulator where you can practice coding and experiment with code snippets. Learn the C++ language. We talked about Visual Studio projects and solutions. We talked about C++ building, which is made up of compilation and linking. And I showed you how to sort of configure all your projects and solutions to specify the compiler and linker flags of your choice to configure your environment for in an optimal way. And sometimes we optimize for speed, sometimes we optimize for file size. There are many compiler choices we can make, and we went through that in part one. Now, in part two, we're going to talk about the automation side of things, because manually configuring projects and solutions in Windows or even on Linux and macOS, it's very manual, and so we want to automate that. And CMake is a great tool for that, and it's a cross-platform tool. So CMake is for cross-platform builds. We're going to talk about the CMake build system, how to use CMake, build environments and compilers. Now, all the example code here, there's a link at the bottom, and it'll give you an example of how to use CMake for Visual Studio. So if you click on the link, it'll take you to the examples, and you'll see a PowerPoint reference material in there as well. Okay. Now, so here we go, CMake build framework part two. So CMake is a cross-platform build system. So what exactly is it, and what does it do? So it's a cross-platform build system. It's not a compiler, and it uses platform-independent configuration files, which are called CMakeList.txt. And it generates the native build files needed for Windows to give you Visual Studio solutions, for Linux to create the Unix make files, Ninja files, and macOS it will create the Xcode projects. Now, from a Windows perspective, if you're using Visual Studio, you can access CMake from the Tools command line and Developer command prompt. CMake comes shipped with Visual Studio, and it's accessible from the command line. There is a GUI, CMake-GUI, if you want to type that into command line. It's not generally available through Visual Studio, but you can download an independent copy of CMake, and you'll find that there's quite an elegant sort of GUI that comes with it. But otherwise, people use it from command line. And I'll show you that sort of right away, what that looks like. So you go to Visual Studio, Tools, Command Line, Developer Command Prompt. In here, you'll see CMake is available. So if you do CMake hyphen version, you'll see the version that we're using, and that just to confirm that CMake is there and available from command line. Now, how do we generate a solution file for Visual Studio? Now, the process is as follows. You'll create, you'll look at the, you'll create a folder structure for your code. You'll have one root folder, and then you'll have multiple subfolders. The subfolders will become your projects in Visual Studio, and the root folder will become the solution. And you will have one CMake list file per folder. And the root folder has a CMakeList.txt file too, and that's where we put the configuration file for the solution. Now, once you created your CMake list text files, these configuration files, you can then open Visual Studio and you run the command line, open command line, and then you type the following command. So you type CMake-G, which means generate the build files. You select your compiler. It's typically in quotes because there may be spaces in the name, and then you give the path to your root project, to the root folder with a CMake list file. So that will look as follows. So if you type CMake-G for generate, I'm not going to generate right now, but I'm going to show you shortly. And if you put in --help, it'll list all the different compilers that you can work with, and then you'll see all the different Visual Studio compilers. You'll see Unix makefiles for Linux, Ninja, and it'll also create the Xcode projects for macOS. And there are other choices too, so it's pretty useful. Okay, so that's the command there. CMake-G, compiler name, and then the path to your root project. So we have to create these configuration files called CMakeList.txt. You'll typically have one configuration file per folder. And we need to learn the commands on how to populate these configuration files. There's not a lot to populate in these files. Sometimes they can look pretty verbose if you want to set different compiler flags. But the basic sort of structure of a CMake list file is pretty straightforward. I'm going to show you the commands first, and then I'm going to give you some example configuration files. So in blue, I've got the main commands that we're going to be using. So for the solution config file, so that's the CMake list in the root folder, we have to provide the name of the solution file using the project command, and then we have to specify what projects to include in our solution using the add subdirectory command. So it's pretty straightforward. Those two operations need to happen: the name of your project, name of your solution, and which projects to include, which folders to include. Then within your project config files, these are the subfolders underneath your solution, underneath your root folder. You do pretty much the same thing. You have to name each project using the project command, and then you have to specify the project type and the list of headers and source files to include. So we would use add library to create a static library or a DLL. We would use the add executable command if we want to create an executable from that project. So, and when we add the library and add the executable, we have to we specify the project type, and we have to list out the headers and source files, and that can be done in a recursive manner. Then the third thing we need to do is provide the path to the include folders and header files using the target include directories. And if there are any dependency projects, we need to provide the target link libraries. So in C++, different folders do not naturally talk to each other. They're completely independent. And if you want to sort of include a subdirectory in a project inside your project, you have to link them using the target link libraries command. And what that will do, that will when it generates your build files for Visual Studio, it will automatically list all the include files that you need and the lib files for that particular file folder for that particular project. So these are the commands. So we're generally going to name the project. We're going to add the projects to include in the solution file, and for the project files, we're going to name the project. We're going to declare whether we're adding a library or an executable. Do we want the project to be a lib or DLL or an executable? Provide the include directories and provide the link to libraries, if any. Now, here's an example solution file folder. So consider a simple C++ math library where the main project is called Analytics, and that depends on two sub-projects called Addition and Subtraction, and the folder structure might look as follows. So we're going to create a math library. That's going to be our solution. That's going to be our root folder. There'll be a configuration file there specific to the solution, and then we'll have three folders within that solution file. We'll have an analytics folder, an addition and subtraction folder. Analytics is going to be the main project in this library. And that project, we're going to create an executable. And the analytics folder is going to have a main file that's going to use an add function and a subtract function. It's a very simple example, just to give you a very clear intuition of what we're doing. So analytics will be the main project within the solution, and then it'll have two utility sort of projects, one called addition, one called subtraction. Now when we want to link projects together to the main project, we generally create lib files for these, so libraries so that we can link against. So we're going to create the addition project is going to be a lib. That will have a configuration file, will have a header called add and a source file called add. Subtraction will be the same. We'll also create a lib from this project. It'll have a configuration file and a subtract header and a subtract CPP. So very simple. And the analytics project, this one will be an executable. This is going to be the one that we're going to run. It'll produce an executable and it'll display some results in this case. So this maybe in a professional environment, the analytics folder will be where you do all your pricing, and maybe you'll have different folders for different things. So maybe you'll have one folder for Monte Carlo, another folder for PDEs, you'll have another one for maybe vanilla option pricing, and then exotics. And then when you want to link them all together to price an instrument, perhaps you have an instruments project. And these folder structures can become pretty big. And the nice thing about CMake is it takes care of all the dependencies, all the linking, all the compiler settings, all done automatically. And so it's a pretty fantastic thing. Now I'm showing you here a very simple example because as the file structure gets bigger, it gets harder to explain. And so it's really for brevity and just to really help you understand what goes where. Now the solution root folder, so the solution root folder on each project requires this configuration file. So you can see one configuration file in each. And the config file defines the project type. Is it going to be a library or it's going to be an executable? It specifies the include paths and all the project dependencies. So let's consider this simple example and let's get it to work for real. Now, the solution config file, so the root folder, so this top one here, looks quite different from the others. So you specify the minimum CMake version. So this and this is where we sort of call the project, so the project command. So we talked about that here. We sort of said name the project and use add subdirectory for the. So we name the solution file, specify the projects we want to use. So here we go. So here's the project. We're going to call it math library. Now math library is we typically want the project to have the same name as the folder, although it doesn't have to be that way, but we typically want to match them. So we're going to call the solution file math library. This and then we specified language is CXX. That's specified too. Then we set the language standards as follows. So I'm using C++ 17. and standards required is on. And then the important part is project and then these targets. So the targets are the subdirectories and the projects and the folders you want to include in your library. So our main project is going to be the addition project, which will be our executable, and that will have and there'll be two other directories called subtraction and analytics. They're independent projects, and we're showing you how to create two libs here, subtraction and analytics, and these will be embedded into the addition executable. And the targets here, this will take care of all the linkage for you. You just have to specify the names. So project gives you the name of the solution file. So the solution file is going to be called math library. Add subdirectory is going to be the list of project folders to include. It's pretty straightforward. Now, I'll show you that very quickly, what that looks in code as well. So you can sort of see, so you see it here. Here's our math library. You got 3 projects within it. Analytics is going to be the main one, addition and subtraction subfolders. And if you double click on the CMake lists, you'll see exactly that file. Let's zoom in a little bit for you. So you'll see the main thing is to specify your project is the math library, add your subdirectories, and you're done. Okay, now for the main project file, so this is for the analytics folder. This is one of the subfolders. We want to create an executable. So we said we could use, we could say add library if you want it to be a library, add executable if you want it to generate an executable. So we want the analytics to generate an executable in this case. So we add executable, we give it a name, analytics, and we specify the include files and the header files and the source files. And it's possible to do it recursively. You don't have to list them all out one by one. So we use the add and executable command. It creates a project that outputs an executable called analytics. And that will sit inside your solution file. Then we list all the header and source files that we're going to include. In this case, we only have one CPP. And you can see the folder structure here. You have one source file called main. Then we want to sort of link 2 libraries to the analytics. So we're going to do some pricing within the analytics, and we're going to use the addition project and the subtraction project. So we using the target linked libraries command, which you sort of see here, you list the project name and then the dependency projects to include, which you sort of see here. Here we add the addition and subtraction projects to the analytics project. Now for the dependency projects, we want these to be libs. Let's have a look at so here, the addition project has 2 files within it, an add header and the CPP. And then here you can sort of see, you can see the same thing really. I'm just showing you for live and on the slides. So the add library creates a project called addition. So add library creates a library project called addition. Now if we use the keyword static, it will generate a lib file. If we use the keyword shared, it will generate a DLL. So it's talking about the C++ runtime framework. Do you want that to be statically linked, or do you want it to be dynamically linked to create a DLL? And now within the library, you have to add all the headers and CPP files to include. So in this case, it's 2 files, a header called add and a source file called add. And then we use the target include directories command to include all the directories. In this case, to include all the all the directories that you want to, the header files, to include all the header files that you need. So we use the build interface, and then you have to sort of say which is build the include files, and then you specify the directory you want to use. And this macro $CMake current source directory just means that you use the current folder. You can just put a relative path in there, or you list the absolute file path as well. So this is saying go to the current directory and any header files in there, add them to my addition project, and so that way all the header files are captured. Now, we would do this again for the addition and the subtraction folder. And as addition is, so this is a static library, and likewise the subtraction folder is exactly the same. Now, once you've created that folder structure, so here we go. Let's see if I can zoom in for you. So once you created that folder structure, so you got here. So math library will be the name of the solution. It'll have three projects, and the each so the solution file has we'll use the root configuration file, and each individual sort of folder will then use its we'll use the local configuration file. And you can sort of see here, we're creating a lib. This one's creating a lib, add library static, and likewise the subtraction folder is also creating a lib. When we go into it, add library, call the project subtraction, and it's going to be a lib. It's going to be a static library, and then finally, we will see that the main sort of project is analytics, where the main is. This one is going to be an executable, not a lib, and it's going to be called analytics. The project's going to be called analytics, and it's going to link to these two sub-projects, addition and subtraction. Now, once you've created all these different configuration files in your folder structure, so if we go back up a level, you would put your source code inside here. So this one's just as one main. Addition has a header and oh, there you go. Let's view it as a details. So the solution file has a header and a source file, and likewise subtraction. Once you have all your files and folders in place with your CMake list files, which are your configuration files, then you're able to sort of generate the solution. Now it's not there, and as you can see now, there's no solution file here. It's just a bunch of folders, the configuration files, and some and your source code. Now, how do we generate the Visual Studio solution file, or how do we generate the build files needed for our platform? So in our case, we want a Visual Studio solution and project files. So after creating the necessary CMake configuration files, you open the Visual Studio command prompt, you navigate to the solution root folder, and then you want to create a folder where you're going to place your solution files. So we're gonna make a directory called build. We're going to navigate to that build folder, and we're going to type this command, and then it will generate us. To generate a solution, a file type, we type CMake-G. We specify the compiler we're going to use. I'm going to use Visual Studio 17 2022, and the double dot here, that's the path to our source folder, which just means go up one level, which is what we say here. Now, we can replace this compiler with Visual Studio 1722 to a compiler of your choice. And if you type after CMake-G --help, it will list the compilers, which is what we saw earlier. And we would pick Unix make files for Linux or Ninja, and for macOS we would use Xcode. So let's do this, right? Let's give that a try. So I'm going to close this and sort of start from scratch, right? So we go, so we open up the CMake developer command prompt. So you go Tools, Command Line, Developer Command Prompt. Right, and then you will navigate then to your build, to your project root folder. So I'm going to just get the root folder from here. So I'm going to do CD. So I navigate to my math library. Now, sorry, a bit trigger happy. Now I'm going to keep this on the screen. I'm going to try and keep these both on the screen at the same time so you can sort of see everything. So let me just expand slightly. Now this is the thing with a live environment. I'm showing you everything live, so obviously things happen. I'm sure we'll be fine. So we navigate to your root folder, which is the math library. And then we're going to create, now you can see there's no build folder here. So I'm going to just create a build folder. So I'm going to do mkdir to make a directory. I'm going to call it build. And you'll see build now is showing up down the bottom. I'm going to then navigate into that build folder. So cd build, there I am. And now I'm going to run the CMake command. So CMake -G, G has to be uppercase, it's case sensitive, so it's generate. We're going to use the Visual Studio compiler. Studio 172022. And if you want to know the compiler names, you just do double hyphen help. We're putting quotes around that because there's spaces in the name. And then the path to the project. Now our project is one level up. We're in the build folder and the root folder is one level up. So I just do double dot, which means one level up. Now when I press this, it's going to generate the solution file, the project files, and everything we need. So let's give that a go. It's pretty quick and it's already done. So now if I go into the build folder, you will see now it's populated with the math library solution. You'll go into the different projects, and you'll see a project file, and you'll also see the well, you see a project file in every folder, and basically you're able to open and build. So let's give it a go. So let's open the solution file. I'll maximize it. Sorry, it hasn't made the text any bigger. So you see all the there you go. So you can see our main file here is an executable. And now what we'll do is I'm going to set the startup project as being analytics because that's our main project. So let's do that. So I right-clicked on it and set it as a startup project. It will turn in bold. We talked about startup projects in part one. Now, when I'm going to pick the release config, we also talked about the different configurations you can select in part one. So please feel free to review that. We use debug for testing and release for for production when we want to give out fast code. Now, after you set the startup project to analytics, you press the run button, and the run button's linked to the startup project, and it's going to launch the executable. So let's do that. It's going to compile, it's going to link, and then after it's linked, it will launch. And you can see what it's done. It's compiled our code, it's linked all our code, and it's printing out some sort of basic results from our main file, which is here. Let's pin it. So you can see we've included the add project and the subtract project. So this wouldn't normally be available without linking. If you go inside the analytics properties, which the properties we'd normally do by hand, which you outlined in part one, you'll see in the compiler section, C++, you will see that it's put the header files for the addition and subtraction folders because we want to link to them. And then inside the linking, it's going to provide the file paths to the libraries that we've created from the addition and subtraction folder, and it's set up those subfolders addition. So this one, if you look in the analytics, sorry, I forgot to show you one last thing. In the general folder where you specify the output, you can see this one's an executable. If you go into the addition project, you will see this one is creating a static library, and then it'll have the relevant sort of include files. We don't have any sub-libraries that we're dependent on this one. So it's taking care of your dependencies. It's done all the linking for you. It's there's really not much to think about at all. It's just really taking care of everything. And the nice thing then is if you were to run the generator on Linux, it would build the exact same sort of dependency tree in the Linux environment. So it's pretty excellent. And you can just generate the file and you're ready to sort of open it up, compile and run, and it'll just work straight out of the box, which is fantastic. It's exactly what we wanted. So I'm going to minimize these screens. Now, so how do we generate the native build projects for Linux, macOS, and other platforms? We simply change the name of the compiler from Visual Studio on the command line to the compiler of your choice. And we mentioned the examples for Linux is Unix makefiles, Ninja, or Xcode for macOS. Now, in terms of CMake Resources, I've written in my newsletter, there's one article here where you can sort of it talks about how to use CMake in a bit more detail, and it gives examples as well. So the links are here. If you right click, it'll take you to the newsletter, and you can subscribe to these newsletters. This one's on how to use CMake, and you'll sort of see lots of examples of how to build and how to compile. And there's lots of resources in there, so that's a very useful resource. Now the links are here as well. Now, there's also CMake.org is the sort of the main sort of company sort of behind CMake, and they have extensive tutorials and guides and examples. That's another excellent resource as well. The link is here. You can also click on the image, and that will take you to the CMake tutorial. And there's a lot of information available here, which is excellent. This is the main sort of resource. And then there's this fantastic book by Craig Scott. If you click on the image, the link is here as well. If you click on the image, it takes you to this page. It talks about paying $30. You don't do that. You just download the guide here. And there's a really good guide on how to use CMake and all the different commands and how to generate files and the like. It's a very, very good guide. It's probably the best guide I've seen. It's really good. Now, in terms of more information, so we've covered we've got some reference slides here in terms of knowing what the folder structure looks like, how to organize your CMake configuration files. We looked at some of the basic commands. I've given you some of the resources where you can find more complex commands and take your CMake building to the next level. Now, in terms of more information, there is a Quant newsletter you can subscribe to where I sort of talk about C++, other programming languages, mathematics, and sort of quant and algo trading in general. You can subscribe to my Quant YouTube channel. There's also my quant trading, algo trading and quant store, and you can follow me on LinkedIn. So there's lots of quant and algo sort of resources available to you. And if you have any further questions or you want any help, feel free to reach out to me on LinkedIn. My contact is here. Please do subscribe to my YouTube channel for more information, or feel free to reach out to me on LinkedIn. So I hope that was very useful, and thank you for your time.